This course is for anyone who wants to learn how to harness the incredible power of neural networks and become a deep learning engineer. You don't have to be an experienced developer or a mathematician. The only prerequisite for this course is knowing quantum mechanics. Just kidding, only basic Python syntax. We'll learn what we need to along the way by building an AI that can do everything from predicting the price of Tesla stock to painting surrealist masterpieces. Traditionally, programming has been about defining every single step for a program to reach an outcome. But machine learning flips that approach. With machine learning, we define the outcome and the program learns the steps to get there. So if I wanted to build an app that can recognize California license plates, instead of writing out code to recognize the hundreds of different features of a license plate, like the shape of certain letters and the colors, we just say, here are some examples of a California license plate, learn the steps you need so that you can recognize it. Or if I wanted to make a bot that could beat Super Mario, instead of writing code for every possible scenario, like jump if you see a Koopa and it's running towards you, we'd say the goal is to get to the endpoint without dying, learn the steps to get there. And sometimes we don't even have an idea of what the steps could possibly be. Like if we're a bank and we suspect there's some kind of fraudulent activity happening, but we're not sure exactly how to detect that or even know what to look for, we can say, here's a log of all user activity. Find the users that are unlike the rest, and it'll learn the steps to detect the anomalies by itself. Machine learning is already everywhere on the internet. Every major service uses it in some way. In fact, YouTube's using it right now to decide which other videos you might like as you watch this. And its usage will only grow over time. It'll be embedded in all of our internet-connected devices. Everything from fridges to cars to personal assistants will be learning and adapting to our needs. And you know that rule that says you need 10,000 hours to master any skill? Well, we'll just be able to offload that training time to our machines and it'll give us superpowers instantly. Anyone will be able to compose a symphony. Alexa, I feel melancholy. Make me a piano piece for this. And add a beat to it. Yo. Anyone will be able to direct a movie. Okay, Google, recreate Star Wars, but put me in it. I Dockerize most of my code now.
You're breaking my heart.
Damn right. With machine learning, if you can dream it, it can exist. And the field is currently advancing very fast as researchers build on each other's work. My neural net sucks. Go deeper. Wow, I just achieved state of the art. There are a lot of machine learning models out there, and one of them is called a neural network. When we use a neural network that's not just one or two, but many layers deep to make a prediction, we call that deep learning. It's a subset of machine learning that has outperformed almost every other type of model almost every time on a huge range of tasks. We'll dive into deep learning more next episode, but this video will just focus on machine learning in general. We usually class learning into three different styles. The first style is called supervised learning. It's where we give a model a labeled data set like car pictures so it gets feedback on what's correct and what's not. It just has to learn the mapping between the labels and the data, and then it can solve some given task like classifying the type of car in an image. It's all relatively straightforward, and we've gotten incredible results from it. The second learning style is called unsupervised learning. This is when we give a model a data set without labels. It gets no feedback on what's correct or not. It has to learn by itself what the structure of the data is to solve some given task. This is harder to do, but more convenient since not everyone has a perfectly labeled data set sitting around. Most data is unlabeled. It's messy and complex. And the third type is reinforcement learning. This is where a model isn't given feedback right off the bat. It only gets it if it achieves its goal. So if we're trying to create a reinforcement learning bot that can learn to beat humans at chess, it would only receive feedback if it won the game. Whereas in the supervised approach, we get feedback every move. And in the unsupervised approach, we never get feedback, even if it won. Unlike the other two learning styles, reinforcement learning is linked to the idea of interacting with an environment through trial and error. So I've got a data set of measurements of different